Okay, today's lesson we're going to talk about coordinate conversion. And in particular, we're talking about how to convert from polar to a rectangular, rectangular being the old stuff, the stuff you're used to, or from rectangular to polar. We're not talking about parametric because we learned that on that first day when we learned about parametric, so we kind of already know how to do that. Let's say we want to go from polar to rectangular. We're going to start by doing x equals r, the cosine of theta, and y, which is equal to r times the sine of theta. If I want to go from rectangular to polar, then I'm going to do the tangent of theta is y over x, and that is a relationship you should already be familiar with from our unit circle days. And then r squared equals x squared plus y squared. Another formula you should be familiar with from our circle days. So this is how we're going to relate these things so that we can change polar over rectangular or rectangular back to polar. We might want to do that because that's what we're more familiar with, or to be able to kind of speak to the masses. As you can see, 11 out of the 12 schooling years of your life, you've always used rectangular. We're spending just a couple days on polar, so it's not as familiar to lots of people. Some fields obviously would want to use this, that's why we're learning about it. So depending on what you go into, you may never see this again, you may see this a lot. Let's start with how to go from polar to rectangular. Starting with example number 1. If I have 2 pi, obviously that's in polar coordinates, 2 being the radius, pi being the theta. If I want to change that over to rectangular, to find my x coordinate, I'm going to do r, which is 2, times the cosine of pi. And I know that the cosine of pi, if I think about my unit circle, that never went away, right? That is at -1, and 2 times -1 is -2. So that's my x coordinate. To find my y coordinate, I'm going to do 2 times the sine of pi. And the sine at pi is 0, and so the coordinate is 0. And my answer is -2, 0. And that's it. Let's look at another example of that. If I have square root of 3 as my radius times pi over 6. I'm going to start with my x. Plug in my r, which is square root of 3, times the sine of pi over 6. I'm sorry, not the sine, the cosine. Remember, that goes with x. I just misspoke. So I have the square root of 3, and then the cosine at pi over 6 is the square root of 3 over 2. You should remember that. If I put that over 1, I'm multiplying square root of 3 times square root of 3, and that would just be 3 over 2. If I'm finding my y, that's what I want to use sine, so I'm going to do square root of 3 sine of pi over 6. And so I have square root of 3 times 1/2, which is the square root of 3 over 2. And my coordinates would be 3 over 2, square root of 3 over 2. Once I find my two pieces, that's all I've got to do, and that's my answer. Be sure that if you're going to use your calculator, so if you have your calculator to do this, you want to use radians. So we've talked about different things this year where I've said you really need to be in degrees, you're going to get the wrong answer. Now I'm saying you really need to be in radians, you're going to get the wrong answer. Obviously, if your angles are given in radians, you want your calculator in radians. Part B for today is how to go from rectangular to polar. So let's practice that. If I give you, for example, number 3, -1 and 1. I'm going to use those formulas. Tangent theta is y over x, and r squared equals x squared plus y squared. So I'm going to start with the tangent piece. The tangent of theta is y over x, 1 over -1. So I'm saying, where is the tangent equal to -1? Because 1 over -1 is -1. It's in quadrant 2, right? Because it's negative. Tangent being negative would have to be in quadrant 2 or quadrant 4. But we know that the point -1, 1 is in quadrant 2, so that's where that's coming from. So I want to know, where's the tangent -1 in quadrant 2? That would be at pi over 4. Again, remember that from your unit circle days, negative square root of 2 over 2 and square root of 2 over 2 would reduce to -1. That's my theta. To find my r, I'm going to do r squared equals x squared plus y squared. Remember, when you're doing that in your calculator, if you have a negative and you're squaring, it's always going to be a positive. Don't let that trick you. So that's 1 plus 1, which is 2. To get r by itself, I'm going to take the square root of both sides, and r is the square root of 2, so my coordinates are root 2, pi over 4. Okay, let's look at one more example of this. Example number 4. I have 0, 2, I'm going to take the tangent of theta equal to 2 over 0. Anytime I have something over 0, it is undefined. So, 0, 2 is in quadrant 1. Where is that undefined? Well, again, that would be where the bottom is 0, so that's where theta is pi over 2. Or up here up top, because that would be 0, 1, and 1 over 0, again, is undefined. This is part of the reason I had you memorize that unit circle. Let's go ahead and find our distance. So 0 squared plus 2 squared is obviously 4. Square root of both sides, and r is equal to 2. So my point is 2 comma pi over 2. And that was it for today's lesson. Let's go ahead and give you the homework assignment, and that is A13, which is page 783, and it's numbers 10 to 26 even. Let me get that in the view for you. There you go. Good luck, and let me know if you have questions.